Hello, and welcome to a special episode of Baxter Breaks It Down, where we're going to take a look at some examples involving applications with right triangles. And by applications, I mean problems involving either an angle of elevation or an angle of depression. So let's check it out. So in this problem here, it says at a point 200 feet from the base of the building, right? So they're talking about this point right here, right? And it's 200 feet from the base of this building. The angle of elevation to the bottom of a smokestack is 35 degrees, okay? So from that point, if you look up at the bottom of the smokestack, that angle there is 35 degrees. The angle of elevation to the top is 53 degrees. So that angle would be from the horizontal line of sight all the way up to the top. That's supposed to be green. Sorry about that. So this angle here, the whole angle is 53 degrees. Got it? Find the height of the smokestack. So I am merely interested in this segment right here. That's what I want to know. That's the height of the smokestack. So how do I use what I've been given to find that? Right. So what I notice is that that's just part of the total height. So the total height being from the very, very top of the smokestack to the bottom of the building. I'm going to call it big H, total height. Okay. That little blue piece is just part of that. The other part of that total height is occupied by this segment right here. And notice that that is a segment of this right triangle. And this right triangle has an angle measuring 35 degrees and a horizontal segment measuring 200. So I can use this right triangle to find this height. Okay, I'll call that segment X, because I know the angle is 35 degrees. That segment that I'm calling X, that segment is opposite my 35-degree angle, and the 200-foot side is the side adjacent. Okay, so the vertical side is opposite the 35-degree angle, the horizontal side is adjacent. So I can use a tangent ratio to create an equation. So tangent of 35 degrees is equal to the opposite, which is X, over the adjacent, which is 200. And then I can use algebra to solve this. So I multiply both sides by 200, and I get that that segment X is equal to 200 times tangent of 35 degrees, which is simply 140.04. So I know that the height from the very bottom to the bottom of the building to the bottom of the smokestack is 140.04 feet. Okay. I can also find the total height, what I call big H. Okay. And I can find that total height because I have that 53-degree angle. Like if I do this for you, remember the whole big angle is 53. The horizontal side is 200. And big H is representing the height of the building with the smokestack. So I can once again write a tangent equation. So tangent of 53 is equal to the opposite over the adjacent. And this right here will give me the total height of the building with the smokestack. So 200 times tangent of 53 is big H, the total height of the building and the smokestack. So the total height is 265.41 feet. Right. So let's kind of like assess where we're at right now, right? We know the total height is 265.41. We know the height of just the building is 140.04. And we want to know just the smokestack. So this is our total height. This is just the building. And so if I subtract these, I will get just the smokestack. So that's what I'm going to do. So let's calculate the height of the actual smokestack by going 265.41 minus 140.04. And so we're looking at 125.37 feet is the height of the smokestack. So I did have to work with two right triangles in this problem and how to find the heights from each of those, and then I could subtract. Okay. This problem is really similar. In fact, if I were you, I would pause this right now and try number 8 because it is similar to number 7. It's just like the diagram's been rotated a little. Okay. So try it. Pause now, try this problem, check back in with me. Okay. So number 8, it says, standing at the midpoint of the Golden Gate Bridge, you observe a speedboat coming towards you. So you are the eye. Yeah. Your eyes are 270 feet above the water. The angle of depression, your horizontal line of sight, changes from 20 degrees to 45 degrees while watching the boat. So first, when you see the boat, your angle of depression is 20 degrees, right? Remember, the angle of depression would be equal to this angle of elevation. So this angle of elevation is also 20, right? So that's the angle of depression when you first saw the boat. And then when you saw the boat again, your angle of depression changed to 45 degrees. So this right here is representing your angle of depression, and that's going to be like congruent to this angle down here. Approximate the distance the boat traveled during the observation period, and that's given by D. So what do you know? What do you need to know, and how can you find it? Okay, so maybe you caught that there was a 45, 45, 90 triangle. Granted, if you didn't, that's okay. Then you probably had to use tangent, right? But maybe you caught that triangle, so 45, 45, 90. And like we know that the legs of a 45, 45, 90 are congruent. So what that means is that since this leg is 270, that this leg here is also 270. Now, if you didn't catch that, or if it did not occur to you, that is okay. You would have used tangent of 45 degrees is equal to 270, like over x, maybe you called it. You would have gotten the same result though, okay? But let me just hide this, okay? The bottom line is that blue segment is 270, okay? I still want to know, like, how far did the boat travel, right? So, like, based on what I've been given, right, and what I haven't found yet, I have this right triangle here, right? And whoa, that was interesting. And that right triangle shows me I have a right triangle with an angle measuring 20 degrees. And that directly opposite that angle is at 270 degree side. not degree, but feet. Or, yeah, feet. And so I can use a tangent ratio once again. And I can find, like, maybe I call this, I don't know, y, I guess. But I can find the total distance the boat would have gone from its original position to directly beneath my line of sight. And I can do that using tangent because I know the opposite. I want to know the adjacent. So I can say that tangent, oh my goodness. I can say that tangent of 20 degrees is equal to the opposite, which is 270, over the whole adjacent side, which is y. And then I can do the algebra. So I can multiply both sides by y, divide both sides by tangent of 20, and ultimately get that y is equal to 270 divided by tangent of 20. And this is approximately 741.82 feet. Okay. And so that is representing the total distance from the boat directly beneath my line of sight. That's what the 741.82 is representing. Okay. Now I simply want to know, how far did the boat travel? So if I know the total distance, and if I know this difference of distances, I can just subtract. So I can take the total distance of 741.82. I can subtract that known distance of 270, and this will give me the distance the boat traveled, which is 471.82 feet. And so it's really similar to the problem prior. It's just, instead of finding the height of the smokestack, you were finding the distance the boat traveled. But we're talking like the same problem, just kind of oriented differently, really. Like both problems use tangent. Right? But that's how we can do some of these more involved angles of elevation and depression problems. Okay, just remember the two angles are congruent. The angle of elevation is congruent to the angle of depression. So in this diagram, angle 1 is congruent to angle 2. Remember that when you are working with these diagrams, okay? And that's how Becker breaks it down.